Hello. Today I want to talk about simple storage service, and I want us to review, yeah, what should be your design approach when you're building on top of this specific service. It's one of the oldest services offering from AWS way back in 2006. I want to talk about best practices. You probably heard about them, but let's just go through that when you're designing on S3. What do you need to know beyond basics so that next time you know you can scale your storage well? My name is Brian, and I am an enterprise storage architect. And let's go. So S3 is what we call object storage. Yeah, S3 is what we call object storage, right? Object storage, right? Um, Object storage. Basically, what this means that S3 is basically flat. And also one of the things that comes with is that it's very low cost and it's cheap and it's very durable. Gives you about 11 nines of durability, and that is there is a lot of clever tricks that go into achieving 11 nines of durability, including when you do a put request to S3, one of the things that you do, it does integrity checking, end to end integrity checking, and before you get that 200 OK error, it has done end-to-end integrity checking. There is a lot about that. We are going to talk about that. We're going to specifically talk about design, scalability, and performance, right? So let's do. S3 is simple. It's very simple to the customer because that was the entire approach for S3. It needs to be very easy for you, the customer. Now, to make it very simple for the customer, it means the design is actually super complex. But the design is also very fundamental. So going back to first principles, that's what makes it such a scalable service. Now, S3 is used from everywhere. From number one, we're talking about people to store their assets, people to store archive data on S3. Right now, people are doing a lot of artifacts for training their models, especially if you integrate this with things like Amazon Bedrock. Yeah. So so far S3 has to scale performance. Yeah. So if you're building on S3, you need to figure out a way. How do I make sure I build when I'm building for S3, it's able to scale beyond what I expected it to without me having to redesign. So we're going to talk about a little bit of that. Yeah. So you look at what I've done here, which I'm just going to give you a little bit a trick how to think about S3. So in this particular case, I'm going to remove that. I'm going to remove that. So this is A, B, C, D all the way X, Y up to Z, right? So this is how you think about S3. So when I create a bucket, for example, this is I have gone into a bucket and then I create a bucket called HPC prod US East one. This is just one I created to test for this. Yeah. So when you create a bucket, this bucket is S3 is mostly virtual. Yeah. At its core, S3 is basically just put and get, right? So you want to put an object and you want to be able to get that object, right? Now there is a lot of things going on. S3 is no longer just put and gets. There's a lot of things built on top of S3, just makes it better. But we're going to talk about it. It's essentially put and get it, right? Um, now, this is all virtualized for you, but in the backend, it's basically storage. We have hard drives running that are basically, storing your data on those specific sectors, and we have a lot of, microservices running to do integrity checking for bits and make sure they don't start to rot. Basically, yeah. So we come here into ABC. So one of the things you need to know, think about it like when you create a new bucket, yeah, you create a new bucket, like let's say this HPC. Let's say this HPC starts with an H. Now go into this A through Z. So this is my way of showing you how this is an abstract form of how S3 works. You can make your own. This is an abstract form. So let's say, for example, this is HPC. So this mine stands with HPC. So H. So when I create a brand new bucket, I go to ABC through H. So my bucket starts with an H. Yeah. So we gather all the H's in one place. A bucket that starts with an A, we put it in one place. A bucket that starts with an R sits in one place. So that every person who creates a new bucket, we take them and then we put them in one place. So you know about what we call co-location, yeah? So you create a bucket and then the bucket go and sits on shared resources, because in the bucket, basically your S3, your bucket needs to use resources. So number one, it's using specific hard drives, it's using power, it's a storage rack, yeah, networking and all those components. So when I create a new bucket, it's basically a new bucket. There isn't a lot of traffic going into it. So we go and group them together and says, you guys, you can share this resource. You guys, a bucket that starts with an M, sit and share that specific resource. A bucket that starts with an O, sit and share that specific resource. Once it starts with a Z, sit and share with this resource. Period. Okay, so it's a new bucket. Now, over time, you create a new bucket, and now you start to to do your deployments, and you're starting to scale up. Stuff starts to happen, right? So you are in this you're collocated with other buckets. So let's say in A you're collocated with, for example, this is H. So this is HPC. Let's say HPC is in H, and it's probably collocated with 100,000 other buckets, right? 100,000 other buckets. Now, what do we usually say? One of the things that we say is that when you look at this documentation, basically tells you best practice and design patterns. It gives you specifically, and this usually tells you that, for example, your application can achieve at least 3,500 put, copy, post, delete requests, or 5,500 get requests per second. Now, note that this is OR. This is not an AND. This is an OR notation. So it means that it can do 3,500 puts, but it cannot do 3,500 puts at the same time it's doing 5,500 gets. So if you're doing 3,500 puts, you have deleted per partitioned Amazon prefix. So we talked about what we call a partition Amazon S3 prefix. We're going to talk about that. So if I'm doing 3,500 to one partitioned prefix, then I cannot do any other thing. I have hit my max. However, if I was doing 5,500 gets, then I cannot do 3,500 puts. In fact, I can do 0 puts, right? So if I was probably doing 2,500, if I was doing 2,500 puts, then that actually gives me leeway to actually do a little bit of gets. But you cannot do 3,500 puts and 5,500 gets at the same time. So it's an OR notation. Kindly note that specific, and it's per partition. Now, think of partitions. So we talked about per partition prefix, right? So a prefix is basically everything that comes after, the bucket. So for example, this could be a prefix, right? So if I copy this, if I copy that and paste it here, this can be a prefix, right? So that is a prefix. Some people think of the prefix as folders. Probably might be it's a prefix. So a prefix is anything. So this is the bucket name, and then whatever follows it, that is a prefix. A prefix can also be the entire path, length of the path of an object like this. For example, if I click on this and then I copy this in itself, if I copy this can also be a prefix. This can also be a prefix. So a prefix can be the entire length of an actual path. This can also be a prefix. Now, you see, this is a prefix and this is a prefix. Now, it's a prefix. That's okay. Now, the prefix needs to be partitioned. What that means is that I need to take this specific prefix and map it to a partition in the backend. If it is not mapped to any partition, then it does not fit whatever 3,500 post delete request. So for example, most people believe that when I say per prefix, it means that if I have a client application that is sending requests to this specific bucket, and I parallelize my requests so that I'm sending them across all these, let's say across all these prefixes in this particular case, then I can scale to, let's say, 10 times. It's because these are 10. Let's say these are 10 prefixes, then I can scale 10 times. Note that that is not true. They have to be partitioned. If all of these are simply in a single partition, then you're still going to be limited to that single partition, that. So for example, we're going to talk about the partition and how you scale. So for example, see that. So there are no limits to the number of prefixes in a bucket. You can increase your read or write performance by using parallelization. For example, if you create prefixes in S3 bucket to parallelize reads, you could scale your read performance to 55,000 reads per second. Partition, note that you could scale. So if you create 10 prefixes in Amazon S3, you can scale. Now these prefixes have to be partitioned. They have to have a partition. If they're not mapped to any partition in the background, then you're still limited to that. You're already still limited to 3,500 per partition. Now think about this. Like I said, so every time I create a bucket, for example, in my H sits. So I create, let's say we have new buckets. At this particular point, there is 100,000, 20 or 100 people who just created buckets that start with an H. So they go sit in that H partition, a single partition. Then, sometimes people create buckets, then they leave them idle. So you can simply not map a specific partition to every new bucket that is created. because that would waste resources. We would run out of resources. So what you do is people come, you create a bucket, they sit on that shared partition until somebody starts to use the bucket. So once you start to scale up your reads, start to scale up your writes, then S3, as magically as it is engineered, it has monitoring and microservices that are doing that. When they start to figure out that, okay, you're starting to overwhelm. Now, one of the things S3 does is it protects all other customers from the effects of noisy neighbor. So you have this bucket and you are starting to scale up S3. Yeah. So if S3 doesn't stop you from scaling up, you might end up, we have somebody who just created a new bucket and they're doing, let's say, 2 uploads per second. Yeah. And then you start to scale up. Yeah. If S3 doesn't do something, you're going to complete and you're going to hoard all the resources that you guys are sitting on a shared resource. So S3 has to find a way to make sure we protect all other customers from your overwhelming workload. So what does S3 do? S3 decides that, okay, you have already hit a limit on a shared partition. We can no longer keep you on a shared partition, so we need to give you your own dedicated partition. So what happens? S3 is going to, in the background, it's going to create its own resources for you, and then it's going to move you from your shared partition into that dedicated partition so that you can, to remove the effects of noisy neighbor from other customers. Yeah. So for example, in this particular case, if you're doing a lot of high throughput, for example, S3 will decide, okay, now let's move you into another partition. Now note that S3 just doesn't move you into this, because S3, in as much as we want to give you performance, we want to give you, we want to make sure all our customers are not, do not get an issue. S3 also has to deal with the design of resources are limited, memory is limited, power is limited, networking is limited, cooling is limited. So we cannot decide that every time you do a spiky workload, we move you to a new partition. That would be detrimental. That a lot of bad things would go wrong really fast. So S3 depends on what we call a consistently breaking barrier. So for example, now this is a new bucket, and now you start to upload to that bucket. Then you start to upload to that bucket consistently for a while, and you're breaking limits. S3 will know consistently. So if you do, for example, you spike workloads for like 3 seconds or 2 minutes, and then you stop, S3 cannot move you, because if you look at the entire workload, you will realize that S3 workloads, in fact, most customer workloads are what we call bursty workloads. So they're not consistent. Yeah. So most customers will have, let's say, for example, this is the whole day, and then they spike quickly, and then they go back to idle. Another customer in this particular case will probably burst really fast in the morning, and then they're idle the whole day. And then you probably have a customer who the entire time they'll just sitting, and then they'll just sit the whole day, and then in the evening they do a quick burst and then go for like 10 minutes, right? So if every time you do a quick burst, S3 moves you to a new partition, we will run out of resources for stuff to work. So S3 needs to monitor you for a consistent number of minutes, maybe even up to an hour, to make sure, okay, yes, this guy is consistently breaching the throughput limits. So we need to start, the process of getting them onto their own dedicated partition. Yeah. That is what usually S3 does. Yeah. Now, at the point in which S3 decides, okay, you've consistently breached your set thresholds, and it needs to move you into a dedicated partition, S3 will send you what you call 503 errors. Yeah. So S3 will give you a 500. It will send you 500 or 503 errors. Yeah. It will consistently send you 500 or 503 errors. So you guys come here and say, it will send you 500/503 errors, right? So S3 will send you anywhere 500, 503 errors, and say, okay, so you're breaching your limits. What you're going to do is, I'm going to send you 503 errors. What that means is, okay, your client is already breaching our limits. Now we're telling you need to slow down. Yeah. Now, when we tell you to slow down, we're going to talk about client side, how to handle that. So there are specific best practices that you need to do client side, so that when a server returns to your 503, your client knows what it's supposed to do. Because every time an S3 returns 503, it's basically telling you, slow down, give me a little bit of time for me to scale. So S3 starts to scale in the back end and says, okay, this guy is already breaching this. So I'm telling him, slow down. So basically give me room to breathe so that I can scale up by myself. And that is what he does. Yeah. So client side, you need to know how to handle 503 errors from S3, which includes things like you need to exponentially back off. You need to slow down. You need to, if you're doing, let's say 3000 3500 TPS, you need to slow down to, let's say, 1000 TPS, and then gradually scale, so that as you scale, S3 also time to scale in the backend to handle your entire, specific workload. Yeah. So that is what I was saying. So you create a bucket like this, it goes into, let's say, a partition like H. But then when you start hitting really hard, it's going to realize, no, we cannot stay in this partition, because, the effect of noisy neighbor is basically going to say, we're going to have these other 100 buckets who are barely doing any work without, throughput and stuff, and they're going to start to experience 500 and 503 errors from noisy neighbor that is not being generated by them. So in order for a consistently good experience for all our other customer, we need to take you out of this shared partition and into a specific dedicated partition so that you can do it. So when you think about design, think about S3 like that. So yep. So think about S3 like that. So let's check. So one thing I wanted to talk about specifically, so in one thing I wanted to talk about there is this. Yeah. So most of the time we know that the only time we get 503 errors are, when, we get 503 errors is when you're breaching these limits. Now, not really. It's not consistently. Not really, because sometimes there's a specific 503. We have specific S3 SLAs that, there are specific 503s that actually happen, and they're within normal rates. So if you do get 500 and 503 errors, in the 0.1% range, then you're operating within normalcy. All you need to do is to implement client side. You need to implement client side logic that basically just we do retry with exponential backoff, so that we just every time we do a retry and exponential backoff, those are most likely to succeed. So if you're operating at 0.1%, 503 errors, that is within S3 normal SLA range, and you're perfectly okay to just implement client-side tracking. And when they start to increase a little bit into the 10%, now you know there's probably an issue that needs to be fixed, and it's probably a design issue. Yeah, that is specifically S3. So for example, let's say, for example, now, like I said, most people would think if I'm getting a 503, it means I'm breaching the 10,000 limit, let's say 5,500 TPS or 3,500 TPS. Not always that. Like I've already said, there is an SLA for how much 500 and 503 are allowed, are allowed within normal operations. Another thing is, in 2020, we got what you call S3 has what you call S3 consistency model. Right? So you have what you call S3 consistency model, right? So they introduced what you call strong read after write consistency. This is something that was introduced to S3, strong read after write consistency. Now, when that happened, if you look at here, let me just talk about Amazon S3. So you go to Amazon S3, so for example, you open Amazon S3. So a lot of this goes to, how do you read your documentation? So if you come here, for example, in this case, we have what you call the Amazon S3 consistency model, right? So we come here and we go here. Yeah, so we have consistency model, right? So this section provides behavior to be expected from S3 when multiple clients are writing to the same aspect. Okay. So in this example, both W1 and W2 finish before the start of reads. W1, W2 before the start of reads. Good. So in the next example, so if write one and write two finish, and then if you do read one and read two, we are good. We don't have a lot of issues there. In the next example, W2 write two does not finish before the start of read one, right? Therefore, might return color Ruby or color Garnet. However, because W1 and W2 finish before the start of R2, R2 returns color Garnet. So this is consistency model that you need to add. Now, one of the things, strong read after write consistency. So strong read after write was basically introduced. So every time, once you're done with the write, when you do a read quickly, it's already strongly consistent. So it also introduced a new issue where, for example, if I take a specific object and I upload that object, so I did something here. So for example, you can see I have an object called concurrent bin. This is something that I basically just did here. If I have an object and then I say I want to upload, I want to do concurrent uploads. Let's say 10 concurrent uploads to that same key. Yeah, that alone is probably going to give you 503. So sometimes you need to figure out that 503, some of them operate within normalcy, within 0.1% range acceptable. Then the others that come from issues like, the introduction of strong read after write consistency. So for example, I did test, one of the things I use is Kiro. So I use Kiro for that. So I use Kiro for that. So for example, in this particular case, signed URLs or element. Okay, give me a second. It's okay. Okay, concurrent upload. So basically use Kiro to just do test. One of the things I use GenAI for is to quickly, write small tests. Just simply write small tests. So wait a minute. Then Kiro will run the following command. So anyway, I'm trying to look at what was the prompt that I gave, but in short, so this basically asked it to create a simple application, Python application, which basically generates a file called concurrent bin and then uploads it to the same key concurrently, 10 concurrent within milliseconds, less than milliseconds of each other. Yeah, and then I told it basically now you can run that. So when I ran and then I told it, okay, also log those response, look for any 503 errors. So you can see that created a 1 byte file called concurrent, executed 10 parallel uploads to the same key within 22 milliseconds of each other, all side between that, okay? Logged all responses to the result of JSON and then detected 1 error, uploaded 5 unavailable. And I did that again. I can basically rerun the application. So I can run the application again. Application. Can sit there and rerun that application once more. So we are definitely concurrent. So for example, if you do you're getting 503 errors, you need to figure out from your end, do you really need to do such concurrency? So this run found 2 errors, 503 out of run found 2 errors, 503 on uploads, 1 and 7. Results saved to uploads to JSON. So out of 10 parallel uploads, we did get 10 parallel, we got 2 503 errors, and those are from what you call concurrent puts to same key. Those also generate. So you need to know that there's a specific reason. There's a lot of things that bring in 503s. It's just that thresholds sometimes. Yeah. Also, one thing I need you to figure out as well. So, like I said, we did talk about this issue where we said in one partition, a single partition, you can do 3500 or 5500, or underline the word or. Now, note that, for example, how would you know whether your partition is going to start throttling, is going to start being throttled or not? So, for example, assume in this particular case, I want to do, so let's say we can get a maximum of 5500 gets, so per partition prefix. So with 5500 gets and 3500 put, copy, post, and delete. So if I come here and say, okay, so let's do 5500. So out of 5500 puts, I'm basically doing 3500. So I'm doing 3500 gets, and then I'm also doing, at the same time, I'm doing, let's say 2500 puts. So this is 3500 gets and 2500 puts. Now, what happens? What you need to know is if you want to check whether this is going to throttle, then what you do is you simply come here and do 3500, then over the total. So you're going to do 3500 over the total 5500 gets, 500 gets, okay, then plus 2500 over 3500 max threshold per partition prefix, right? So what do you do? So if you do calculations for that specific, you get 3500, divide by 5500, you get 0.633. So you get So you get 0.63336, for example, 0.636. Yeah. And then you're going to come here and add 2500 over 3500. So 2500 over 3500 over 3500. So 0.7. So you come at 0 0.7142, right? So if you add these two, yeah, if you add these two, 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 okay. So if I add these two, you can check this. I add 0.6 plus 0.7. This comes to above 1. So if my answer goes above 1, then I know that we're already breaching the partition limits of this specific partition. Yeah. So 0.6 plus 0.7 comes to about 1.3. That is already past the 1 threshold. So if anything below 1, you know that your partition, the single partition, can handle those specific requests. If it goes above 1, then you know that partition is going to start being throttled while it starts to scale. So this is something you're supposed to specifically know about that, about S3 partition by itself. Now, like I talk about partition. So like I said, when we're coming here and saying partition, yeah. So this is for example, this is a prefix. This prefix needs to be partitioned. Now, partitioning is something that happens automatically depending on how you design, how you scale your design, right? How you design S3 will partition depending on how you do your initial design. Yeah. Now we can also partitioning can also be done manually. You have to reach out to AWS support if you're the people with enterprise plan and stuff like that. You'd have to reach out to AWS support and ask them to do partitioning for you. But we're here because we do not want you to get to that point. Now, sometimes you have to do partitioning, especially because, like we've said, automatic partitioning by AWS happens over a consistent breaching of those set thresholds. So if, for example, you are hitting your bucket really hard, you probably will not want to wait for about 1 hour for it to actually start scaling. So if you're going to hit your bucket really hard, you're one of those high performance compute companies. Let's talk about, one of those really, really huge companies. It would be in your best interest to reach out to AWS support before, so that they do partitions, they map internal partitions to your prefixes before you start sending those requests to to your S3 bucket. So how do you design this so that it scales? Now, there is a concept of what you call cardinality. There's a concept of what we call cardinality, where you want to make sure cardinality to the left, right? So look at, for example, this is for example, the way that you see my bucket, you can see my bucket has a lot of 0.6K. It's divided into about 3 random hashes that I generated. This is one of the ways that I do my designs so that I can actually scale. So normally, if, for example, you have, let me use this specific bucket. So this is prod query. Let me use prod access logs, for example. So let's look at this. So let's look at this bucket. For example, this is that bucket, and then we go to USist1, and then we go to that. Then you go to, you see, we have a date naming scheme. So 2026. Then we go to that is February, and then we go to 24th. So this is 24th. So if you copy this S3 URI, for example, and then come here and paste it here, for example, I won't come and paste it. Come here and paste it. So it's okay, it's okay. Just leave that. If I come here, good. So I want to show you something. So this is one of the example of what you are not supposed to do. Yeah. Cardinality is to the complete right. So for example, in this case, we have ourselves a bucket. This is the name of the bucket, and then we have this part, and then we have USist1, then HPC bucket, and then we start with 2026, and then February, and then 24th. So what happens if we start to breach set limits? Let's say 3500. What happens? S3, basically, the way that S3 scales when you're breaching limits automatically is that it looks directly in your path. It will look through your path to find something that is unique. In the unique thing, it's going to look for anything that is unique, and then it will auto partition on that unique string. So now if I look at this, for example, prod access logs here, bam, okay. So that is prod access logs. So for example, let me see. For example, product access logs. You know what? Let me click this. Let me click this. Let me click this. So copy S3 URI. Let me click this. Okay. So I'm going to come here. Let me take this a little bit. Yes. So look at this. So if you look at this, I'm looking at S3 everything. Okay, bam. So I look at this, February 24th, 2026, that, and then you can see 206. This is one. And then I'm taking I'm uploading these logs again. So I consistently upload these logs. So I come back here, and then that is log 1 and log 2. So I copy log 2 again. Let's copy the S3 URI for log 2 as well. Let's copy that for log 2 as well. There you go. See, now we're looking at this. Everything is the same. So if you look at along this path and we are starting to breach our limits and we are uploading objects, look at this. Everything here is the same. This entire path is the same. Yeah. Where does the path start to change? The path starts to change at the end of this string. So this is 007, so 06 that. So if S3 wanted to auto partition, S3 will auto partition at the very end of this so that it creates a partition and maps it to this very end. Let's do a third one, which is probably this. Yeah. So we're going to come here and say, let's see, S3 URI. So we're going to, let's do a third. 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 Sure about that. So we're going to copy S3 URI basically. Now I'm going to come here and say, okay. Right, see, so everything, if you look at all these three, everything here, logs, A1, everything here is consistent. So S3 is looking to, I want to auto partition because I'm already breaching my limits. So it needs something unique, some unique string of characters so that it can auto partition on. But if it looks at all the logs that it's uploading, they're all writing onto the same path. And then the only uniqueness starts to happen at the end. So cardinality begins to the complete right. What means is that today, if it starts to partition, it's going to partition at the very end of that partition. So it's going to probably 0700, it's going to auto partition at the very end because that is when the string starts to change and become unique. Now, what does that mean? That means it's a problem. Why? Because so this is 24th. So this is 24th. What happens when it is 25th? Or for example, in this case, we use 23rd. So if that happened on 23rd, so 23rd, the same thing is going to happen. So if I'm breaching my limit, S3 is going to auto partition itself at the very end, of those strings of characters, because everything that precedes it, it's consistently the same. You can see from that everything is same, and then we come here, cardinality changes. That is a problem for you. So if you want to scale, then you need to figure out a way to partition early. You need to partition early so that you can reuse. So the problem is 23rd. So if we create that partition today, it's going to auto partition on, let's say it's going to create a partition, let's say in this particular case on 2026 or probably 04E. It auto partition on that. Now the next day, for example, it goes into 25th. It's going to go through the same problems where it's uploading to a different partition, and then we created a partition yesterday that we probably we throttled the whole day and for up to 1 hour before it was created, and then by the time it was created, our workload was nearly almost done. So every single day you're basically creating hotspot, you keep on throttling, you create new partitions, and then they remain cold after the next day and stuff. So we don't want to do stuff like that. We want to find cardinality, move cardinality to the left so that we partition early so that the next day, if stuff happens, we can reuse the same partitions that we had already created so that if we throttle today, our throttling today basically saves us from throttling tomorrow because now we are using our partitions. So how do you do that? Now that is basically how in my buckets, I basically generated hash. So this has to be done both client side and server side. Yeah. So I will come and do a prefix naming. So for example, myself, you can see I have OJO. I created this unique three hash layer, 06K, 0J0, that. Yeah. So after I created this unique layer, I make sure that client side, when I'm doing uploads client side, yeah, I parallelize my uploads across all these unique strings. so that when I'm doing uploads, they're being parallelized across unique string, so that when because we're not going through a single specific path, so that we are parallelizing our uploads across this unique string, so that you see now I am starting to partition just after the bucket name at the root of my folder, so that when I'm doing uploads, I was starting to scale up, then it looks through every object that I'm uploading. But because I'm uploading them to different prefixes, yeah, which have this specific random hash that generates, then it's going to look at them, then it's going to find there's a lot of uniqueness. Hash basically generates a lot of uniqueness. So it's going to start to partition very early, because at first you might have this object coming in here, being tested in a test.parquet. So you can see the path basically is this. So you can see the path is this. But the next object, because I'm using client-side parallelization, is going into another unique prefix. So when it looks at those and then it wants to start auto-partition, then it realizes I have so many partitions. So it partitions early, so that the next person who basically the next person who uploads past those partitions basically finds we already pre-partitioned that, so that now you don't have cold data. You don't have a partition that you created yesterday. It's sitting there, it's not being used, and then we're having hot partitions again. So this is how you do your design on S3. This is server side, and then you also have to go client side and enforce everything that you need to go client side. Now, right now, client side is actually pretty much easy because AWS has done everything for you client side on AWS S3. Thus, we have things like AWS Common Runtime, CRT. So these libraries are they're basically C-based libraries for you to use because the AWS has already handled everything for you. So in this particular, we're talking about S3, this specific library. It's going to do everything that needs to be done for you. For example, in this particular case, it's going to do request splitting. It's going to improve throughput by automatically splitting the request into pass-sized chunks and performing parallel upload, DNS load balancing, and stuff like that. Yeah. So for example, if I come here and I do this, for example, so if I pick any, in 2020, S3 introduced what we call multi-value DNS answer, so that if I go, for example, if I look at S3, if I look at S3 endpoints, for example, right? If I look at S3 endpoints in this particular case, so this is what I'm getting, get S3 endpoints. And if I come here and pick a normal S3 endpoint like US East 1 or this, let's look at the normal S3 endpoint. So US East 2, that is Ohio. Then if I come around and they basically do a dig for that, if I dig for that endpoint in this particular case, right? Okay, look at that, enter. So I get a multi-value DNS answer. So those are 8. Those are 8 results that I get. And each time that I do that, I get a different answer. Look at this 3.5, they're different from what I got here. Why? Because when you're making requests to S3, we do not have a predefined path. The path is known during the DNS lookup process. And how do you do that? If you look at how multi-value DNS answer activity 3 is done, you get the hosts that you get, the 8 hosts that you get are the ones that are actually healthy. And that's why we say when you're doing client side using probably SDKs, when you do retries most likely succeed, because if, for example, one of the issues that you're being blackholed is because one of the requests that you sent through a specific host, you found that it got busy, it got overwhelmed. So when you do a specific retry, then you do a new DNS lookup, then you're routed to a healthy host, and then chances are your request actually goes through. So these are basically client-side things that we talked about. So we've talked about these are what you call common runtime libraries. So that, for example, if you're going to use something AWS SDK, so AWS SDK for Java, or Java version 2. So we have version 2 that is already out. So we look at SDK Java, SDK 2, for example. If you're going to be sending requests, you're sending a request or probably doing uploads for files that are bigger than 5 MB. Let's talk about your files are like, let's say in the 100 megabyte range, then you need to speak specific async clients, yeah, Java clients. Let's see SDK. Let's see configuring service clients, client configuration externally, AWS SDK. So AWS SDK for Java v2 clients, S3 clients. So S3 clients, right? So let's look at S3 clients. S3 has a specific client. Let's see if we can find it there. So like I said, all these are perfect. Yes. So if you look at here, we have like we talked about S3, CRT-based clients have common runtime already built into them. So they're going to do stuff like that. So for example, this is AWS CRT-based clients. So they provide the same asynchronous API operations as Java-based clients, but with greater performance. So if you want better performance, especially for uploading larger files, then your best bet would be to use AWS CRT-based clients, right? And then we also have Java-based S3 async client with multipath enabled. Yeah. So less performance than the AWS CRT-based client. Yeah. Provides a synchronous API, supports automatic parallel transfers, multipath when you enable them. And then now, if you're going to use anything less than 8 MB, I mean, that less than 8 MB, that you should probably use Java-based async client without multipath enabled or S3 sync client. Those are things that you probably need to know from the client side. And then we also have things like automatic retries. One of the things that I usually talk about is S3 as its core, for example. Let's talk about S3. S3 is probably divided into this is common knowledge. Yeah, so S3 is probably divided into three. In a high level format, abstract format, S3 has probably three parts. Yeah. Now, most of us know S3 as just something, we know S3 as, we use it to store data. And this is the most common part to the normal person, which is the storage layer. Yeah. So this is the storage layer for S3, right? That is the S3 storage layer. Figure it out. Yeah. This is where we actually store our bits and bytes and we make sure, data is stored. Now, the next one, we have what you call an index layer. We're going to figure out what the index. But before we talk about, we have what you call the front end layer. Yeah. Let's talk about S3 front end. Yeah. In order for S3 to have to be as scalable as it is, it was imperative that we create a front end layer. That means that the entry point to S3 isn't just a single, it's a fleet of instances. And that's why when we did our DNS answer, it provided us with specific hosts. This is basically when you send a request to S3, you are routing them via these front end hosts, and then they will find their way into the storage layer. And how do they find their way into that? The index layer. So index, just like what we say that, we say this is where do I find, I'm doing a GET request. Where do I find it? The index layer will tell you this is where we have that specific byte. This is where we have that specific bit. So index is almost as it's the core of S3 because without index, without somebody to tell you where everything is, it's all, you cannot access your storage layer. Yeah. So front end, this is front end was actually built to scale S3 because with front end, we have things like how do I scale? For example, if I have a 100 megabyte file, yeah, 1 MB file, 1 MB file that I want to upload, megabyte file that I want to upload to S3. So I have a 1 megabyte file I want to upload to, 100 meg, let's make that 100 meg that I want to upload to S3, yeah. If I use a single connection, to S3, for example, depending on how probably say it's probably going to take, let's say, theoretically 5 minutes. No, this is just a number. Yeah, obviously it doesn't take 5 minutes to upload that, but we're just testing. 5 minutes. Now, a much better way would be S3 is big. S3 is huge. We want to take advantage of S3 scale, to make our workload better. Yeah, so 100 megabytes is probably going to be limited. So if you do 100 megabytes, you're limited by, number one, the connection, that single connection. You're also limited by, if it's one host, you're limited by the resources of that single host. Why would you want to restrict yourself for such a robust, offering by AWS? Yeah, what do? Instead, you can split this into 5 megabytes files, right? Or 8. And then you do 5 divided by that is 20. So you can either decide to do 5 20 megabyte files in parallel using five connections, or you can do 5 20 megabyte files in parallel. So you basically route those through different front ends. They will go through different, each of them goes through a different front end hosts, and then they're in parallel. Yeah, so this 5 minutes might go down to up to around 6 seconds because you're doing them in parallel, and you are now not you're not limited by a specific footprint like a single host or stuff like that. Good thing about this is that when an issue happens in terms of network and latency, then you don't, when you set a retry at your client side, the client doesn't retry the whole thing. It only retries the specific path and connection that had an issue, which is probably say a 5 MB file, and it's easily succeeds. In fact, at the CRT-based clients, we have what we call a P9 value. So we have the percentiles, so that the last 5% of requests are automatically dropped and retried immediately, so that to increase, how fast that goes. And that is how you specifically scale. So you basically send all those in parallel. You're not limited by a single network. You're not limited by a single front end host. You're basically parallelizing, and that's how it works. Yeah. So S3 specifically works like that. Now, most specific robust services build and say, okay, we were young, but now we've grown robust. So we need to find a way to build so that our system doesn't crash from all the weight. S3 engineering is a little bit tricky, where they figured out a way that instead of trying to fight and build so that we don't crash from all the robust and scale, how about we build scale into S3, so that the more S3 scales, the happier we become, because the scale of S3 makes our system even more stable. That is how S3 is basically designed. The engineers basically did some clever tricks. One of the things you remember when I talked about robust, peak robust, yeah. So where one of the things I like to talk about S3 is what we call Ouroboros, right? So if you know about anything called Ouroboros is basically a snake that is eating itself, right? If anybody knows about a Ouroboros coin program, so a Ouroboros is basically S3 is built in terms of AWS team looks at how customers are using S3 and then build it that way. And then the same way, once they do that, the customers also need to understand how AWS builds S3 so that they do that. So it's a very mutually exclusive. You as a customer need to understand how S3 is built, and S3 also needs to understand how customers are using S3 so that they can build around that. So each of them needs to understand each other so that they can build scalable application. Now, for example, like S3 understands that most workloads are bursty. Yeah, most customers will not have consistently burst, let's say, high throughput workloads the entire time. No, most of them have specific timelines, and something gets bursty and then it drops. Yeah. So for example, that would be so how does S3 predict how this works? Yeah. Now S3, if you look at this, for example, if you look at this thing that I showed, like for example, you have a customer here in the morning, does bursty workloads, it's flat. One does it in the middle, flat. Then one does it in the end. Now, if you take a step back from looking at each individual, S3 looks at the mean of each of those customers, and then it uses that to specifically model S3, right? So the mean collapses, because if this guy is doing bursty workloads in the morning, this is doing this, and then the system becomes very predictable when you take a step back looking at the chessboard from taking a step back from the chessboard. That's basically how S3 is built. Like, for example, if you come here to the storage layer, for example, if you come here to the storage layer, for example, I think I did write about storage. How is it that S3 is able to scale that high? Now, one of the things that we have an issue with, I usually give this specific thing where if I have a hard drive here, I have this specific hard drive. This specific hard drive is 1 terabyte in size, right? It's 1 terabyte in size, 1 TB. I have a 1 terabyte in size. So this is 1 terabyte in size, for example, right? 1 terabyte hard drive. And let's assuming we are designing a storage system. Now this storage system, this guy probably has 1 terabyte worth of file, and then he wants to store this 1 terabyte into S3. Now, a simple way, we have a lot of 1 terabyte files. A simple approach would be one customer's terabyte file goes into 1 terabyte. It's simple, it's efficient, it's very easy to handle. You don't have to do a lot of complexity in terms of your system design. Yeah. The problem is this is not a scalable way. Number one, S3 is rated for 11 nines of durability. So if all customers' 1 terabyte data is sitting on a single hard drive, what happens if that hard drive fails? Hard drive fail, and they fail all the time. All the time. This is something that is well anticipated. It is known that hard drives fail. So that is a terrible idea for storing data. Yeah. So, and one of the things, let's talk about performance wise. So if this specific hard drive is rated at 100 megabytes per second, right? It's rated at it means that if I'm uploading 1 terabyte to S3, leaving out latency and network issues, I am limited to 100 megabits per second, meaning for 1 terabyte, I am limited by my throughput. So I am limited by my storage footprint. Now that is not. S3 basically, the way that it's scalable, it says that the bigger it gets. So every customer within S3 has gets to use all, gets to scale through all the storage system, storage layer. Yeah, that's one of the things. Now we say S3 has enough drives to go to the ISS and back. Yes. So why are you limiting yourself? Why would other hard drives sit there empty, blank, and then you're basically limited by that throughput? No. So S3, what it does is, whenever you try to upload a file, S3 just picks another one by random files, and then specific chunk of bytes are written to different drives. So in this particular case, instead of one, S3 might choose to write you 100 terabytes, your 1 terabyte data, into, let's say, 100 drives and divide it by that. So if they're writing to 100 drives by 1 terabyte, how much is that? Probably, I don't know. Is it 100 megabytes per drive? And then now, if we're doing it in parallel, it means that we might essentially reduce the time to write from, in this particular 1 TB 100 megabyte might come from, let's say, an hour to about 50 seconds, because number one, we are parallelizing, and then we're not limited by our storage footprint, which is 1 terabyte. So we can burst through S3. Same thing that comes for performance. Same exact thing. When we want to basically read the data, we just, yeah. Now, write is probably much better because let's not talk about that, but yeah, you get the entire concept of, you bust outside of your performer. If we didn't do this, it means people who have, let's say, if let's say each drive is not less than 1 terabyte, then it means that somebody who has, let's say, 5 gigabytes of data can only be limited to 1 gigabyte to one single drive. That would not be very fair. Yeah. So even if you have 5 gigabytes, even 5 gigabytes, S3 might decide to write your data on 10 or 12 hard drives, or it doesn't matter. You just need to take care of performance. That way we can spread the load so that you don't have hotspots in S3 drives where we have places of hot data and cold data. Yeah, S3 make sure to spread data. So for example, when new hard drives come in, they spread all that cold data into it, so that you don't have a new hard drive coming in with hot data. Because we also have to, in this system design, also has to account for things like actual physical data and cooling of your data centers. So you don't want to have very high hotspot. You need to spread everything equally and stuff like that. Anyways, that's as much as I can talk about today. If you have any questions, I'm going to, in the description, I'm going to leave my LinkedIn. I'm going to leave my LinkedIn there, or my email. If you have any questions, you need specific designs about storage, things like Elastic File System, FSX for Elastia for high performance compute and stuff like that, or generally you just want to get into specifically AWS, you can reach out to me. Otherwise, do have yourself a nice day. Cheers, guys.